Now, let's explore R squared, also known as the coefficient of determination. R squared is calculated using the following formula. In this formula, yi represents the actual values, y hat I represents the predicted values, and y bar is the mean of the actual values. R squared measures the proportion of variance in the dependent variable that is predictable from the independent variable, S. It ranges from 0 to 1, where 1 indicates a perfect fit. Let's calculate R squared for our example. To calculate the total sum of squares, TSS, we first need to find the mean of the actual values. The mean is calculated as the sum of all actual values divided by the number of observations. Adding the values, we get 12 divided by 4, which equals 3. First, we calculate the total sum of squares, TSS, and the residual sum of squares, RSS. Using the values from our example, we can compute R squared. A higher R squared value indicates that the model explains a larger portion of the variance in A data. Here are some key takeaways about R squared. First, R squared measures the proportion of variance explained by the model. Second, R squared ranges from 0 to 1, where 1 indicates a perfect fit. Third, a higher R squared indicates a better fit, but it doesn't imply causation. Finally, R squared can be misleading if the model is overfitted. By understanding R squared, you can better evaluate how well your regression model explains the variance in your data. Now, let's explore adjusted R squared, a modified version of R squared that accounts for the number of predictors in the model. Adjusted R squared is calculated using the following formula. In this formula, R squared is the regular R squared, N is the number of observations, and K is the number of predictors in the model. Adjusted R squared penalizes the addition of unnecessary predictors. It only increases if the new predictor improves the model more than would be expected by chance. Let's calculate adjusted R squared for our example. Substituting these values into the adjusted R squared formula, we get. Simplifying the calculation, we get an adjusted R squared value of 0.8. Notice that adjusted R squared is slightly lower than the regular R squared. This is because it penalizes the addition of predictors that do not significantly improve the model. Here are some key takeaways about adjusted R squared. First, adjusted R squared penalizes unnecessary predictors. Second, it is always less than or equal to R squared. Third, it is useful for comparing models with different numbers of predictors. Finally, it prevents overfitting by discouraging the addition of irrelevant variables. By understanding adjusted R squared, you can better evaluate the trade-off between model complexity and explanatory power. Let's understand AT&D by visualizing our data points on a 2D plane. Here, we have 5 data points representing some observed values. The red line represents the mean of the y values, which is 3. This line serves as a baseline for understanding the total variance in the data. The yellow dashed lines show how each data point deviates from the mean. These deviations are crucial for calculating the total sum of squares, TSS, which measures the total variance in the data. The TSS is calculated by summing the squared deviations from the mean. For our data, the TSS is 2.5. Now, let's fit a regression line to the data. This green line represents our model's predictions. The equation of this line is y equals 0.5x plus 1.5. The blue dashed lines represent the residuals, which are the differences between the observed values and the predicted values. These residuals are used to calculate the sum of squared errors, SSE. The SSE is calculated by summing the squared residuals. For our model, the SSE is 1.0. R squared represents the proportion of variance explained by the model. It is calculated as 1 minus the ratio of SSE to TSS. In this case, R squared is 0.6. Which means that 60% of the variance in the data is explained by our model. Now, let's discuss adjusted R squared, which adjusts for the number of predictors in the model. Here, n is the number of observations, and k is the number of predictors. Adjusted R squared penalizes the addition of unnecessary predictors. Substituting the values into the formula, we get adjusted R squared is 0.467, which is lower than R squared. This is because adjusted R squared penalizes the model for having an additional predictor. I hope you understand R squared and adjusted R squared and found this video helpful. If you enjoyed it, please give it a thumbs up. Subscribe to support the channel. Leave a comment and share it with your friends. Your support means a lot. See you in the next video.